So, good afternoon. Today I will be discussing stoichiometry. So, ano nga ba yung stoichiometry? Stoichiometry, pinapakita nito sa atin yung relationship between the relative quantities of substances taking part in a reaction or forming a compound. So, from here, we can learn how many moles of a substance can be used in a reaction given a certain grams nung sample natin. So, mas maintindihan nyo siya further sa ating discussion. So, first of all, we must know about chemical equations. So, a chemical equation consists of a reactant and a product. So, an example of this will be the formation of water molecules. So, mag-react tayo ng hydrogen gas, ng oxygen gas, then we will form water molecule. So, kailangan sa chemical equation din, marunong tayo mag-balance. So, we'll try to balance this out. So, dahil meron tayong 1 mole ng H2 and meron daw tayong dalawang oxygen dito, pero sa kabila, isa lang. So, lagyan natin ito ng ito. Ulitin ko lang. H2 plus O2 will yield H2O. To balance this out, we have to make sure that all the atoms in the reactant have the same number on the product. So dito, isa lang yung O natin, but dito dalawa. So we can put 2 here, para dalawa din oxygen natin. In this case, naging 4 naman yung hydrogen molecule natin. So we can put 2 here. So, ganun lang simple mag-balance ng equation. So this also involves stoichiometric coefficients. So itong nilagay natin na integers before the reactants and before the product, before the compounds, this is what we call the stoichiometric coefficients. So stoichiometric coefficient shows the number of molecules in the compound. It also gives the ratio of the reactant to the product. So, paano ba natin sabihin na ratio yan? So, in every 2 moles ng H2, if you will see it in the equation, will produce 2 moles ng ating H2O. So, in 1 mole of O2 naman, nakaproduce siya na H2O. So, that is the ratio. So, we must be also familiar with the chemical symbol, ano bang meaning nila, and what is its composition. So, for the example, we have here chemical symbol of water, H2O. Since wala ka nakikitang number or integer before, this means that you only have 1 molecule of water. Parang given na siya, equivalent na siya sa 1. So, ang composition niya, because may subscript tayo ditong 2, so meron tayong 2 hydrogen atoms and 1 oxygen atom. So, dito naman sa second example, we have here integer 2 as our stoichiometric coefficient. So, this means we have 2 molecules of water. So, this would consist 4 hydrogen atoms and 2 oxygen atoms. So, paano nangyari yung pinagmutay natin yung coefficient dun sa subscript ng ating atom? And this another example is the hydrogen peroxide with the chemical symbol H2O2. So, this also means that we have 1 molecule of hydrogen peroxide. So pag binagyan ko na ng 2 dito, that would be 2 molecules of hydrogen peroxide. So this consists ito ng 2 hydrogen atoms and 2 oxygen atoms. If nilagyan natin ng 2, magiging 4 H atoms, magiging 4 oxygen atoms. So that should be clear. So an example here is this 1 methane molecule plus 2 oxygen molecules, which will yield 1 carbon dioxide molecule and 2 water molecules. So we must remember the law of conservation of mass, which states that matter is neither created nor destroyed in a chemical reaction. Kaya dapat kung ilan yung ginamit natin sa reactant at kung ano yung ni-react natin sa reactant, siya din yung mapoproduce in the same number. However, syempre different compound. So here are some of the chemical reactions na ma-observe natin kapag nag-react tayo ng certain compounds. So first one is the combination reaction. So the combination reaction follows the formula of the A plus B is equal to AB. So this means that the one molecule or the one compound will combine with the other reactant compound and magko-combine sila. So example here is the magnesium plus oxygen gas will produce magnesium oxide. So malalaman natin mamaya saan ba napunta tong 2, etc. So for the decomposition reaction, we have here AB is equal to A plus B. So ang example niya ay ito. So dito. 2Na and 3 will yield 2Na plus 3 nitrogen gas. So unlike the combination reaction, dito naman, from a combination of compounds, we will be decomposing it. So maghihiwalay sila. So yung cation natin hiwalay, ganun din yung ating anion, which naging gas na siya. So for the single displacement reaction naman, this follows the formula A plus BC is equal to AC plus B, where A should be more reactive than B. So makikita natin siya dito sa active series of metals. So dito sa example natin, our AA is iron, then we'll react it to 2 moles of hydrochloric acid. So our B here is this H. So kung makikita natin dito sa table, kung si hydrogen ay this reactive kay iron, kaya naman iron can react with hydrochloric acid and replace H and form perichloride plus hydrogen gas. So kung yung i-react natin, for example here, ay yung copper, so hindi siya magiging possible kasi si copper ay least reactive kay hydrogen. So kung magiging ganito, this will not be possible. So reaction cannot occur. For the another chemical reaction type, so we have the double displacement reaction, or also known as exchange or metathesis reaction. So this follows the formula AB plus CD is equal to AC plus BD. So here's the example. So yung perichloride natin, i-react natin with sodium hydroxide, and nag-form siya ng ferric hydroxide and sodium chloride. So yung Fe natin, which is the cation, nag-react siya sa anion nung kabila. Ganun din yung cation nito, nag-react siya sa anion nito. So we have the product. So one of the things that you must always remember is the mole. So kailangan tandaan nyo lagi ito yung volume to. So 1 mole of a something is equal to 6.022 times 10 raised to 23 of that thing. So this is also known as the Avogadro's number, or F. So experimentally daw naman, 1 mole of carbon-12 has a mass of 12 grams. So ito lang yung nakikita natin sa periodic table. So let's see in this table, we have different elements: aluminum, copper, iron, sulfur, iodine, and mercury. So sila ay may mga individual masses which can be found in the periodic table. However, in every 1 mole, ang values nila parehas lang. So here are the sample problem. So white phosphorus consists of P4 molecules. It is spontaneously ignites on contact with air. The other allotropes of phosphorus are not as reactive. If there are 0.350 moles of P4 molecules, how many P4 molecules are present? How many P atoms are present? So since given na sa atin na every 1 mole, meron daw tayo 6.022 of that thing. So 0.350 mole P4, we'll divide this with the Avogadro's number, 6.022 times raised to 10 raised to 23. Since molecules P4, so pag kinumplete natin, will give us ay baliktad. So baliktad yung gawa natin. We should multiply this pala. So this lang natin. So for every 1 mole daw ay meron tayo 6.022. So multiply natin siya. 23 molecules over 1 mole. So we have 2.1 times 10 raised to 23 molecules P4 or 2.11. So sabi naman, pinapahanap sa atin kung ilang atoms daw ng phosphorus ang present. So for letter B, since meron na tayo na-compute na molecules ng P4, so we will use that 2.11 times 10 raised to 23 molecules. And sa 1 molecule ng P4, meron tayong 4 na atoms ng phosphorus. So, multiplying it by 4, you get 8.43 times 10 is to 23 atoms. Next. So, computing for the molar mass. So, molar mass is the mass in grams of 1 mole of a compound. So, it can be obtained by getting the sum of the masses of the atoms present in the compound. So, para ma-compute natin siya, we have here hydrogen. So, ang molecular weight ng hydrogen ay 1.01 grams times mole. Phosphorus naman ay 30.97 grams per mole. And oxygen is equal to 15.99 grams per mole. So para makuha natin yung molar mass ng compound na to, we will multiply it to ilan ba yung present na atoms. So hydrogen, may 3 daw siya. Phosphorus, may 1. And the oxygen, may 4. So ayan. Solve na natin. 3.03 grams per mole. Ito naman ay 30.97 grams per mole. And this one will be 63.96 grams per mole. Yung total natin, since sum of the mass will get 97.96 grams per mole. So, approximately, yun lang. So, ito naman. So, in a given mass in grams, we can identify the moles of a certain compound and the number of particles present in that compound. So, kapag hanapin daw natin yung moles in a given mass in grams, we will just divide it by the molecular weight of the compound. And from that moles, we can get the number of particles by multiplying it to the Avogadro's number. So if we will reverse the process, so para makuha natin yung moles from the number of particles, we divide it by the Avogadro's number. So alala niyo pa ba? So this is the 6.022 times 10 raised to 23. Lagi dapat memorize. So to get naman the mass in grams per moles, we multiply it by the molecular weight. So sample problem. What amount of in moles are represented by each of these samples? So for letter A, we have the mass and we're going to get the moles Fe2O3 present. So ang molecular, pinaunang gagawin natin is to identify the molecular mass ng ating Fe2O3. So the molecular weight of Fe2O2 is 159.69 grams per mole. So, magaya ng nasa diagram natin, pag galing tayo sa mass, and we're going to get the moles, we divide it with the molecular mass. So, 150.0 grams Fe2O3 multiply reciprocal since i-divide down natin dito. So, grams per 1 mole Fe2O3, which will give us 0.9 mole. For letter B, the same way, since we are given mass, but in milligrams. So, ang gagawin natin dito, identify first the molecular weight of NO2. So, molecular weight ng NO2 ay 46.006 grams per mole. And meron daw tayo dito 10.0 milligrams NO2. But since our molecular weight from the molar mass is in grams, we have to convert first this milligram into grams. So, dapat medyo familiar din tayo sa mga conversion factors. So, 1,000 milligrams is equal to 1 gram. So, and then we'll multiply. I will divide this with the molecular mass, 46.006 grams. 1 mole NO2. So we can cancel this out. Here, matitira na lang yung mole. We'll get 2.70 times 10 raised to negative 4 mole. So for the last one, we have 1.5 times 10 raised to 16 molecules BF3. So para makuha natin yung moles, we have to divide it into the Avogadro's number, 6.022. 10 is to 23. Per 1 mole BF3 is equal to 2.49 or 2.5 times 10. 10 raised to negative 8 mole. So, hope that's clear. So another sample problem we have juglone, a dye known for centuries, is produced from the husk of black walnuts. It is also a natural herbicide that kills off competitive plants around the black walnut tree, but does not affect grass and other non-competitive plants. So the formula for juglone is C10H6O3. So first daw, hanapin natin na yung ating molar mass ng juglone. So, yung ginawa natin kanina. C has 12 grams per mole times 10 equal to 120 grams per mole. RH is equal to 1.01 grams per mole multiplied by 6 in 6 to equal to 6.06 grams per mole. And our O is equal to 15.99 grams per mole times 3 is equal to 47.97 grams per mole. So computing na for the molecular mass, add up all this, you get 174.03 grams. So, sample daw, 1.56 times 10 raised to negative grams of pure juglone was extracted from black walnut husk. So, how many moles of juglone does this sample represent? Since meron na tayong molecular weight, magiging 1.56 times 10 is to negative 2 grams juglone. So, para makuha natin yung moles, i-divide natin siya sa molecular weight. So, divided by 174.03 grams will be equal to 8.9 or 8.96 times 10 is to negative 5 mole. Another sample problem. Ascorbic acid or vitamin C with the molecular formula C6H8O6 is an essential vitamin. Cannot be stored by the body and must be present in the diet. What is the molar mass of ascorbic acid? Vitamin C tablets are taken as dietary supplement. If a typical tablet contains 500 milligrams of vitamin C, what amount moles and what number of molecules of vitamin C does it contain? So we first compute for the molar mass of the ascorbic acid. So ascorbic acid will be equal to 6 times molecular weight ng carbon, which is 12.01 grams per mole, plus 8 times molecular weight ng H, which is 1.01 grams per mole, plus 6 times molecular weight ng O, 16 grams per mole. So this will be equivalent to 176.01 grams per mole. So, next pinapahanap sa atin ay ilang moles daw at ilang molecules ng vitamin C does a 500 milligrams contain. So, 500 milligrams. We have to first convert it to grams. So, there is 1,000 milligrams in 1 gram. Then, saka natin siya i-divide sa molecular weight. For 1 mole. So, ano natin siya? 500 divided by 1,000 times 176. We get 2.83 na 9 times 10 is to negative 3 mole of vitamin C. For C, so number of molecules We have here the moles. So 2.839 times 10 raised to negative 3 moles. And para daw makuha natin yung molecule, we multiply it with the Avogadro's number, which is the 6.022 times 10 raised to 23. So calculating it, we'll get 1.71 times 10 raised to 21 molecules. So for the next one, we will be talking about percent composition. So there are two common ways of describing the composition of a compound in terms of the numbers of constituent atoms. So siya na na-describe natin kanina. Nakikita natin sa subscript. And in terms of the percentages by mass of its elements. So percent composition can be calculated with the formula by dividing the amount of a compound times its molecular weight times 100 divided by the molecular weight of compound. So for an example here, we have ethanol. So kanyang molecular formula is C2H6O. So first, we have to get the molecular weight of the whole compound. Dahil ang ginagawa natin kanina, 2 times 12, since ito yung molecular weight ng carbon, 24. Hydrogen, 6 times 1 grams. So oxygen, 1 times 16 grams per mole. We'll get 16 grams per mole, and adding all of this, we'll get 46 grams per mole. So, para mukha natin yung percent composition ng lahat ng atoms, ng per atoms, we divide the amount ng carbon sa molecular weight of ng compound. Saka natin siya i-multiply sa 100. So, kagaya nito, solve na natin. May 24 grams per mole ng carbon sa ethanol. Then we'll divide it with the molecular weight na compound na 46 grams per mole times 100. We'll get 52.17%. So, molecular percent composition naman ng hydrogen. Sa computed natin kanina, we have 6 grams. So the 6 grams will also be divided with 46 grams times 100 will be equal to 13.04%. And our oxygen, same way, 16 grams divided by 46 grams times 100 is equal to 34.78%. So, sample problem. Carbon is a substance that occurs in two forms, having different arrangements of the atoms but the same molecular formula, C10H14O, and mass. One type of carbon gives caraway seeds their characteristics, and the other type is responsible for the smell of spearmint oil. Compute the mass percent of each element in the carbon. So first, we have to compute for the molecular weight of our carbon. So here, we have 10 carbon still, 12 grams per mole, 14 times 1 grams per mole. Oxygen natin, 1 times 16 grams per mole. Carbon will have 120 grams per mole. 14 grams per mole, 16 grams per mole. So our molecular weight is equivalent to 120 plus 14 plus 16 equal to 150 grams per mole. So the percent composition naman, so percent C will be from 120 natin, 120 grams per mole over 150 grams per mole times 100 is equal to 80%. So our percentage naman, so 14 grams per mole divide natin sa total molecular weight, 150 grams times 100 is equal to 9.33%. So 9.33%. So percent oxygen naman, same way, 16 grams per mole over 150 grams per mole times 100 will be equal to 10.67%. 10.67%. So pag pinag-add mo lang din to, this will all be equivalent to 100%. So let's proceed naman with the empirical and molecular formulas. So empirical formula, the smallest whole number of mole ratio of the elements may or may not be the same as the molecular formula. So if the two formulas are different, the molecular formula will always be a simple multiple of the empirical formula. So for example, the empirical formula for hydrogen peroxide is HO, while its molecular formula naman ay H2O2. So parang minultiply yan ng 2 to. So parang makuha kasi natin ang MF, we have here empirical formula. So means that yung N natin dito ay 2. So empirical formula HO2. So molecular formula na natin ay H2O2. Molecular formula, on the other hand, is the two or more substances with distinctly different properties can have the same percent composition and the same empirical formula. So the subscripts daw in an empirical formula indicate the simplest whole number ratio of moles, the elements in a compound. The simplest ratio does not always indicate the actual number of moles in the compound, since ito nga yung empirical formula natin. Molecular formula, ina-specify naman yun yung actual number of atoms of each element in one molecule or formula unit of the substance. So para magkapag-solve tayo, pag meron tayong given mass ng elements, we have to always assume 100 grams yung samples natin doon. And then we'll be able to compute for the grams of each element. So, para naman makompute natin yung moles of each element, we'll be multiplying the grams in its atomic weight. And to calculate for the empirical formula, pinakompute natin ang moles ng each element, multiply natin dyan sa calculated mole ratio. So, let's try a problem. Propane is hydrocarbon, compound composed only of carbon and hydrogen. So it is 81.82% carbon and 18.18% hydrogen. What is the empirical formula? So, like you see, there's a diagram kapag given daw tayo ng percent composition, ang mass percent composition, i-assume natin na may 100 grams tayo ng sample para makuha natin yung grams ng each element. So first, we'll have to compute for the grams of each element. So C will be 81.82% divided by 100. Since percent siya, kailangan siya i-decimal times 100 grams. So this will give us 81.82 grams. So makakancel lang naman yung 100. We do the same on the H. So 18.18% to 100 times 100 grams equal to 18.18 grams hydrogen. So usually, we can say here na kung ilan na yung percent, we can directly convert it as grams. So pag pinagpas mo tong dalawa to, it's equal to 100 grams. So next naman na gagawin natin is get the moles. So ito yung grams. So next one is the moles. Para makuha natin yung moles, again, we will be dividing the grams with the molecular weight. So molecular weight ng carbon ay 12 grams for 1 mole. So we'll get 6.8183 mole C. H 18.18 grams divided by the molecular weight of the hydrogen is equal to 18.18 mole. So once we get the moles, so kailangan natin na makuha yung coefficient by dividing this to the lower value. So dito sa dalawang to, ang mas mababa, of course, is the 6.81833 mole. So we divide this by 6.81833 mole. So then 6.81833 mole. So we'll get the coefficient will now be this one, C is equal to 1, and H will equal to be 2.666. Since coefficient natin dapat is always a whole number, so hindi pa natin pwedeng consider tong 2.666. So we have to think of a integer na pwede natin i-multiply dito kung saan magiging whole number both. So you can do a trial and error or trial and error. So kung sa 2 natin to, magiging 2. Ito naman magiging 5.332. So hindi pa rin siya whole number. Let's erase that. Let's try naman ang ating, let's try 3. So ayan, let's try 3. So 3, multiply natin siya sa 3. We have yung 3. Ito naman, 2.66 times 3. We'll get 7.998. So this is approximately 8 na din. So bakit ito i-round off naman natin kasi sobrang lapit na niya. Compare dito, 2.66. So we cannot round this off agad. So ang magiging empirical formula na natin ay C3H. So another problem. Analysis of a chemical used in photographic development fluid indicates the chemical composition of 65.45% C, 5.45% H, and 29.09% O. The molar mass is found to be 110.0 grams per mole. Determine the molecular formula. First, we have to compute for our empirical formula. So, kagaya na ginawa natin kanina, we have to get the grams. And since naka-percent naman na, and we will just divide it to 100 and multiply it to 100 grams, you can see that we have 65.45 grams C, 5.45 grams H, and 29.09 grams O. So once we get the grams, so we will get the moles. So we divide this with 12, kanyang molecular weight. So this will be equal to 5.454167 mole C. Ito naman, divide natin sa kanyang molecular weight. We'll get 5.45 mole C. So then, sa kanyang molecular weight, which is 16 grams per mole, we have 1.8125 mole H. So, hindi pa natatapos dyan. We will divide all of this into the smallest value na na-compute natin. So, we divide this all with what? 0.8125. So, then 1.818125. So, computing now, we'll get a coefficient of ito, magiging 2.99. 2.99 divided 1. So, approximately, pwede na to. So, 3. So, our empirical formula now is C3H3O. Susunod pa ba? So, the next one, para makuha naman natin yung molecular formula, first we got to compute for the empirical weight. So, dahil may empirical formula na tayo, we can compute for the empirical weight. So, that would be the same as computing for the molar mass of a compound. So, 3 times molecular weight of C, 12 grams per mole, plus 3 times molecular weight of hydrogen, plus molecular weight of oxygen times 1. So this will be equal to 36 plus 3 plus 16 equals to 55 grams per mole. So to compute for the molecular formula now, so may given tayong molecular mass. N is actually molecular formula, sabi ko kanina, is equal to empirical formula N. So, paano ba natin makuha yung N? So, N is equal to molecular weight of the molecular formula over the molecular weight of the empirical formula. So, both are already given and computed. So, we just have to substitute the value. So, we have here molecular weight of the molecular formula is equal to 110.0 grams per mole. And the molecular weight ng empirical formula na compute natin, 55. 55 grams per mole. So, dividing the two, we have N is equal to 2. So, ulit natin dito. Empirical formula natin is C3H3O. And then we have our N2. So, our molecular formula now will be C6H6O. Another problem. So first, given na sa yung grams, so we don't have to compute for it again. So, ang kukunin na natin ngayon is the moles of the carbon and moles of the hydrogen. So, from our grams, we'll be able to get the moles by dividing it to the molecular weight. It's equal to 4.165 mole C. So, for our hydrogen naman, we have 10.47 grams divided sa ating molecular weight ng hydrogen, which is 1 grams per mole, is equal to 10.47 mole hydrogen. So, para makuha naman natin yung coefficient, again, we will divide it to the smallest value. So, yung 41.65. So, we divide both. So, ayan. The coefficient now is 1 for carbon. And dito naman, 2.513. But since sabi nga natin, kailangan na siya ay nasa whole number. So, let's try multiplying it this to 2. So, we get 2. Ito naman. We'll get 5.026 or approximately 5. So our empirical formula now will be C2H5. So the next step naman, gaya na ginawa natin kanina, ay we get the empirical weight. So empirical weight would be 2 times 12 grams per mole plus 5 times the molecular weight of hydrogen. So we'll have 29 grams. 29 grams per mole. So, meron tayong 29 grams of per mole. Ang molecular formula natin, again, is equal to empirical formula N. So, for N, have here the molecular weight of the molecular formula, molecular weight divided by molecular weight of the empirical formula. So, given na yung molar mass natin, which is the 58.12 grams per mole, divided by our computed empirical weight, 29 grams per mole, or N now is equal to 2.004, or approximately 2. So, molecular formula will then be C2H5 divided by 2, so magiging C4H ng molecular formula natin. So, hope that's enough para masanay kayo sa pagkuha ng molecular formula. Given lang ang mass. Yeah. Next one is the balancing chemical equations. So, kagaya na sabi ko kanina, it's important that we know how to balance chemical equations. So, the same number of each type of atom must be found among the reactants and products. So, ito yung steps paano magbabalance ng equation. So, first, we have to determine what reaction is occurring. Then, we write the unbalanced equation. So, we balance this equation by inspection, starting with the most complicated molecules. So, determine what coefficients are necessary so that the same number of each type of atom appears on both reactant and product sides. So, kagaya kanina, dapat equal yung number ng atoms sa reactant at number ng atoms sa product. So, you can do this by trial and error. So, sample problem. At 1000 degrees Celsius, ammonia gas, NH3, reacts with oxygen gas to form gaseous nitric oxide, NO, and water vapor. This reaction is the first step in the commercial production of nitric acid by the Oswald process. Balance the equation for this reaction. So, first, sabi, determine the reaction. So, meron daw tayong ammonia gas na nireact natin with oxygen gas. Then, nag-yield daw siya na nitric oxide and water vapor. So, simply H2O in gas. So this one is still an unbalanced equation. So what we're gonna do is, let's try the trial and error. So tingnan muna natin. So our N here is equal naman na. Our H here is not equal. Ang O natin, kasi may 2. So 1O plus 1O is equal na. So ang hindi na lang equal, yung ating H. So paano nga ba? So let's try to add 2 here. So hindi na mag-i-equal yung N natin. We will add 2 din dito. Para ma-maintain natin na equal yung ating N. So we have here 2N. We have here 2N. So our H naman, 2 times 3 is equal to 6. Ibig sabihin ito, pwede natin lagyan ng coefficient na 3. So para 3 times 2, meron tayong 6 hydrogen atoms. So let's check naman our oxygen. So dito sa ating product, meron tayong 2 moles of oxygen, 2 atoms of oxygen, plus 3 atoms of oxygen. So we have 5. Dito 2 lang. So we can multiply this by 5/2 or 2.5. So 2.5 times 2 is equal to 5. So equal na sila. But since we can't write a fraction as a coefficient, we multiply this, we divide or multiply this whole equation with 2 para ma-cancel out natin tong 2 sa 5/2. So multiplying it by 2, we'll get 4NH3 plus 5O2 yields 4NO plus 6H2O. Yan. So check natin if balance na. So we have 4N. We also have 4N here. H3. So 4 times 3, we have 12H. Dito naman, 6 times 2, we also have 12H. So balance siya. So let's check naman kung balance na ang ating oxygen. So we have here 5 moles of O2, which means we have 10 oxygen atoms. So dito naman, meron tayong 4 O atoms plus 6 O atoms is also equal to 10. So balance. We balance the equation already. Sorry for you. So now let's proceed with the stoichiometric. So this is the steps in computing for our stoichiometry. First, we have to balance the chemical equation. So pasadahan na natin siya kanina. And then we convert the known mass of the reactant or product to moles of the substance. Use the balance equation to set up the appropriate mole ratios. So makikita natin yan sa coefficient ng ating reactant at ng ating product. So ito yung stoichiometric coefficient natin na diniscuss ko sa pinakauna. And then, use the appropriate mole ratios to calculate the number of moles of the desired reactant or product. So convert from moles back to grams if required by the problem. So makikita natin tong steps na to once we try some sample problems. So ito, grams of substance A. To get the mole, we use the molar mass of A. Then para makuha natin yung moles of substance B, we use the coefficients of A and B from the balance equation. So napakahalaga na tama yung balance equation natin. So you have to be very careful when it comes to balancing. Kasi maapektuhan nito yung buong sagot nyo. Lalo na kung pinapahanap ito sa inyo lahat. And then, yan, itong diagram lang magiging guide natin sa pagsasolve ng mga problem. So, sample problem. Solid lithium hydroxide is used in space vehicles to remove exhaled carbon dioxide from the living environment by forming solid lithium carbonate in liquid water. What mass of gaseous carbon dioxide can be absorbed by 1.00 kg of lithium hydroxide? So first, we have to write the equation first. So sodium lithium hydroxide. So ayan, sodium lithium hydroxide daw. So we can remove solid lithium hydroxide. Yan ang kanyang chemical symbol, solid. Tapos, nireact natin with carbon dioxide. And then, nag-produce daw tayo ng lithium carbonate. Lithium carbonate. So, dapat marunong din kayo mag-formula writing, which can be discussed in another session. And liquid water daw. So, ito na yung ating reaction. So, let's check if balance na ba siya. So, Li, hindi siya same number. So, ibig sabihin, dito pa lang, nakita na natin na hindi balance ang ating equation. So, to balance it, ito na yung balance equation natin. Susulat ko na lang. So, 2 LiOH plus CO2 Li2CO3 plus H2O. So, check natin. Ito lang naman yung dinagdagan natin. So, 2 lithium din here. OH plus may O pa dito. So, and 2H, ating oxygen ay 3 sa ating reactant. Dito rin ay 4, 4, since may 2 tayo dito. So, we have here 4 oxygen then, and then the carbon is 1. So, yan, balance na yung ating reaction. So, hinahanap sa atin ng problem, ilan daw yung na-absorb na carbon dioxide ng 1 kilogram of lithium hydroxide. So, kagaya na sa diagram, meron tayong grams ng substance A. At ang hinahanap sa atin, yung mass na na-absorb ng substance B. So, ito yung gagamitin natin hanggang dito. Hindi, hanggang yan mo. So, given 1.0 kg LiOH. Gamitin daw natin yung molar mass ng A. So, kg to. So, alam naman natin na ang molar mass, ang unit niya ay grams per mole. So, let's convert first into grams. So, 1 kg is equal to 1,000 grams. So, saka natin siya i-divide sa molar mass ng A. So, lithium hydroxide molar mass will be equal to 23.94 grams per mole. Tapos, makukuha na dito natin yung moles. Gamitin naman daw natin yung coefficients of A and B from the balance equation. So, coefficient niya, since masasolve natin dito ay yung 2 moles ng lithium hydroxide. So, parang dimension analysis lang. Every 2 mole ng lithium hydroxide na magagamit natin, ang ma-absorb niya ay 1 mole ng CO2 as shown here. You know, every 2 moles, ang mag-react ay 1 mole ng carbon dioxide. Then, makukuha na natin dito yung moles ng ating substance B. So, we have to use naman daw the molar mass of B. So, molar mass ng B natin, multiply natin. So, molar mass ng carbon dioxide ay 44 grams per mole. And then, makukuha na natin yung grams ng substance B. So, calculate lang natin sa calcu. We'll be canceling this. Then, so, computing now, we'll get 1,044 divided by 23.94 times 2. So we have 9.2 times 10 raised to 2 grams. So, answer natin dito ay ang na-absorb daw na carbon dioxide ay 9.2 or times 10 raised to 2 or simply 920 grams every 1 kg of lithium hydroxide. So now let's proceed in computing for the percent yield. So the amount of product predicted from stoichiometry, taking into account limiting reagents, is called the theoretical yield. So limiting reagents muna tayo. So ano nga ba tong limiting reagents natin? So we should be familiar with the limiting reactant. So, limiting reactant, ito yung pinagbabasehan natin kung ilan ba yung ipoproduce nating product. So, for example, here is the sandwich analogy, if you're already familiar. So, for example, meron tayong 4 breads plus 2 meat plus 1 cheese para makabuo tayo na yung sandwich. So, ilang sandwich yung mabubuo natin from this if 1 sandwich must have 2 bread, 1 meat, and 1 cheese. So, kung titingnan natin dito, so, ang limiting reactant natin again is yung cheese. Kasi nga, isang sandwich, kailangan ng isang cheese lang meron tayo. So, kung magagawa lang natin na sandwich, isa lang. 1 sandwich lang. Isa lang yung cheese natin. So, our limiting reactant here, therefore, is the cheese. So, be careful pa rin na hindi porket siya yung pinakamababa, siya na yung reactant natin. So, we still have to find it out. So, once nakuha na natin yung limiting reactant, so, makikita natin siya sa sample problem mamaya. Another example. So, let's proceed. So, here is our sample problem. Nitrogen gas can be prepared by passing gaseous ammonia over solid copper 2 oxide at high temperatures. The other products of the reaction are solid copper and water vapor. A sample containing 18.1 grams of NH3 is reacted with 90.4 grams of copper oxide. Identify which is the limiting reactant. B. How many grams of N2 will be formed? And C. the reaction gave 6.63 grams of nitrogen. Experimentally, what is the percent yield? So we have to write the reaction first para mahanap natin yung limiting reactant. Excuse me. So, nitrogen gas daw can be prepared by passing gaseous ammonia. So, gaseous ammonia, i-react daw natin siya sa solid copper 2 oxide. So, ayan. And magpo-form siya na nitrogen gas as well as copper and water vapor. Let's see if this equation is already balanced. So yung N natin and N2, hindi pa rin sila balance. So we have to balance it. So ito na yung balance natin. It will be 2 NH3 plus 3 CuO. And then we have here N2G plus 3 Cu plus 3 H2O. So you can pause this para ma-check nyo kung paano ko ba nakuha yung balance equation. Or you can, para matry nyo siya yourself. So the next one, pag nakuha na natin yung balance reaction, can now identify the limiting reactant. So may given tayong grams ng NH3. So sabi meron daw tayong 18.1 grams. And meron naman tayong 90.4 grams CuO. So para ma-identify natin yung limiting reactant, kailangan nating hanapin yung moles na na-consume ng 18.1 grams NH3 and moles na na-consume ng 90.4 grams CuO. So, paano ulit natin kunyang moles? So, we have grams. We divide it by the molecular weight of this. So, hanapin natin kung ilang moles ng N2 ang mapoproduce from this 18.1 grams and 90.4 grams CuO. So, we first have to look for the moles of NH3. So, we divide its grams by its molecular weight. So, we have 17 grams NH3 per 1 mole. And then, gamitin natin yung stoichiometric ratio. So, in every 2 mole ng ating NH3, nakakapag-produce tayo na ng 1 mole N2. So, para hindi kayo malito kung sino yung nasa taas o nasa baba. So, usually, tinitingnan ko lang dito ay yung units. So, kailangan ko mapalabas yung mole ng N2. So, kailangan ma-cancel ko yung mole ng NH3 and grams ng NH3. So, makita nyo yan, ganyan. May iwan na lang yung mole ng N2. So, calculate na lang with the values. So, 18.1 divided by 17 times 2. So, we'll have 0.532 moles N2. So, write ko lang. Meron tayong na-compute na 0.533 moles N2 in 18.1 grams NH3. So, let's compute naman kung ilan yung mapaproduce nating moles ng N2 in 90.4 grams of copper oxide. So, 90.4 grams copper 2 oxide. Divide natin sa kanyang molecular weight, which is So, ang molecular weight ng copper oxide is equal to 79.55. 79.55 grams CuO. So, base sa ating chemical equation, every 3 mole daw na CuO, makapag-produce tayo ng 1 mole N2. So, cancel natin this. And then, we'll get the moles of N2 na produce. So, ang na-produce natin na mole na N2, 0.379 moles N2. So, kagaya ng sabi ko kanina, hindi porket mas konti, siya na yung limiting reactant. Sino kinompute natin? Nakita niyo naman. Ang limiting reactant pa natin ay the copper 2 oxide. Kasi kaunti siya na na-produce na moles ng N2. So, compared sa moles na na-produce ng 18.1 grams na ammonia. So, now, sagutan na natin yung A. So, our limiting reactant is the copper 2 oxide. Pero naman daw, how many grams daw mapoproduce sa reaction? Since ito na ang ating limiting reactant, so ito na yung gagamitin natin. Na-produce daw ay 0.379 moles N2. So, ika-grams lang natin siya. So, 1 mole ng N2 ay 28 grams. Multiply lang natin siya sa molecular weight ng N2. So, yan. Multiply na natin. So, we have 10.6 grams N2. So, grams ng N2 in form. So, sabi naman, if the reaction gave 6.63 grams of nitrogen experimentally, what is the percent yield? So, percent yield natin ay equivalent to theoretical yield so balikan natin. So ito yung ating theoretical yield. And given natin na yung actual yield, kasi yun daw yung na-produce experimentally. So yung actual yield natin, yun yung napoproduce natin, nagawa natin. Yung theoretical yield, we can get it by computing it from the actual reaction. So, ayan. Percent yield is equal to dito, actual yield over theoretical yield times 100. So, given na yung actual yield natin, just 6.63. And we have computed for the theoretical yield na 10.6 grams. So, times 100. So, our percent yield now is equal to 62.5% yield. So, ibig sabihin, 62.5% yung na-produce lang natin from the 100% yield expected natin makaproduce ng process. So, kung naglalab kayo, this means that probably may error na ginawa during the experimentation, kaya hindi natin na-consume or na-produce lahat ng nitrogen gas na dapat ma-form. So, that's it. Thank you very much. I hope that you understand what I have shared. So I will be sending a post-assessment na pwede nyo sagutan as a practice para sa mga magiging quiz nyo later on. So thank you. Please also answer the evaluation form that I will be sending. And if you have any more questions or may nalilito pa rin kayo, chat nyo na lang ako. And then I'll try to discuss it again, step by step. Yun lang. Thank you.